Good day, everyone. We are here again for Mathematics Meal, a wonderful program that is designed to help students as far as the study of mathematics is concerned. I'm still your friend and brother, Engineer Ike Okechukwu. Thank you. Today on Mathematics Meal, we are going to look at a beautiful and wonderful topic known as surd. It is not that surd that is in your mind as SWORD. No. This one is used for war. We are not here for war. We are here to do mathematics. Thank you again. All right. Today, the objectives that we intend to cover as far as the study of surd is concerned are 11 in number. But we are not going to exhaust all of them in one class. So we are going to break it down. So by the end of the lesson, by the time a student have participated in the study of surd, the person will cover these 11 objectives, starting from the meaning and types of surd, then the basic rules in surd. Then we also look at basic and non-basic forms of surd. Then we also consider similar surd, and then we'll see how we can add surd and also subtract surd. Then we move on to look at conjugate surd. We consider also multiplication of surd, and then we also look at rationalization of denominators of fractions that are surd. We also look at equality of surd, and then we look at the equations involving surd, and finally we consider square roots of what? Of surd. These 11 objectives are the things that we are going to, the objectives that we are going to cover as far as the study of surd is concerned. Don't go anywhere because it promises to be an interesting class. All right. We are going to start immediately by looking at the meaning and types of what? Of surd. The meaning and types of surd. Meaning and types of surd. All right. What do we mean by surd? What do we mean by surd? Surd. All right. I define surd this way. Surd or surds are roots of numbers that cannot be expressed as whole numbers or rational numbers. Roots of numbers that cannot be expressed as whole numbers or rational numbers. They are known as what? Surd. Now, look at the keyword here, roots. You know we have different roots. We have square root, we have cube root, we have fourth root, we have fifth root, and so on and so forth. Now, any root of a number that you cannot express as a whole number or rational number, that root is what? Is a surd. In other words, what it means is that when we leave numbers in square root or cube root, those numbers are said to be in what? In surdic form. All right. So let's explain this further. If I have square root of 4, square root of 4 is 2. Square root of 9 is what? Is 3. But let's look at this. Supposing I say square root of 2. It is not 1. It is not 1. It is not 1. I know that someone wants to say 1. It's not 1. Square root of 2 cannot be 1. Square root of 2 is around 1.414 and so on. Yeah, square root of 2 is not 1. Remember, square root of 4 is 2, because when you multiply 2 by itself, you have what? You have 4. We are taking the positive values anyway. Square root of 3. Square root of 9 is 3, because 3 times 3 will give us what? Will give us 9. We know it's plus or minus, but let's just consider the positive values only. So square root of 2 is not 1, because 1 times 1 will not give us what? 2. So square root of 2 is 1.414. There are other digits that will follow. Now, surds are roots of numbers that cannot be expressed as whole numbers or what? Irrational numbers. Now, square root of 2, we cannot express it as a whole number, because you can see this is a decimal. And it's not also a rational number. You remember You remember that a rational number is a number that has a terminating decimal or repeating word decimal. That's a number we can express as a ratio or in fractional form. That's rational number. Now, square root of 2 is neither terminating nor repeating, so it's not a rational number. So because we cannot express square root of 2 as a whole number, square root of 2 is what? A surd. Square root of 2 is a surd. So any number whose square root or cube root cannot be expressed as a whole number or rational number, that number is what? Is a surd. So if I have square root of 5 now, I cannot express square root of 5 as what? As a whole number. Then square root of 5 is also what? It's also a surd. So when we leave numbers in root form, those numbers are in what? Are in surdic form. So if we have this now, we can say, we can comfortably say now, in other words, when we leave numbers in root form, the numbers are known as surds. So when we express numbers, when we leave numbers in root form, the numbers are known as what? Surds. Now, for our study, we are going to look at only square roots. That's the surds that involve what? Square root. The surds that involve square root. Remember, we say generally roots, but in our study, our interest will only be on the surds that involve what? Involve square root. So in our study, we shall consider surds that involve square root signs only. So we are not going to be looking at surds that have cube root, that have fourth root, that have fifth root, that have any root. No, apart from what? The ones that are expressed in what? In square root form. All right, examples of surds. Examples of surds. Can have root 2, root 3, root 5, root 7, 2 root 5, 10 root 7. We can also have 2 plus root 6, 4 minus root 3. We can also have 5 root 2 plus 3 root 5, etc. Okay, all these are surds. All these are surds. Now, the square roots in surd, these square root terms in surd are known as what? Radicals. The square root terms in surd. So we take note of that. The square root terms. The square root terms in surd are known as radicals. They are known as radicals. So square root of 2 is a radical. Square root of 3 is a radical. So square root of 2, square root of 3, square root of 5, etc. are all radicals. They are all radicals. They are radicals. Not that they are mad anyway, but they are radicals. They are radicals. That's what we call them. These are radicals. They can move. They can move. You see how they will move, how they will be moving by the time we continue with surds. So they are radicals, but they are not mad, because in mathematics we don't entertain madness. We don't. All right. So far, we now know the meaning of what? Of surd. We said that surds are roots of numbers that cannot be expressed as whole numbers or rational numbers. So in other words, when we leave numbers in root form, the numbers are known as what? Surds. So when we leave numbers in root form, the numbers are known as what? Surds. So anytime you leave numbers in this form, in root form, the numbers are known as what? As surd. We have given examples. Also remember that we said our interest in this surd is to look at surds that involve only what? Square root sign. So we'll not be looking at surds maybe cube root of 7, something like this. No. Every of our business will center on surd, which was surds that contain what? Square root what? Sign. Okay. Finally, in this section, remember we are looking at the first objective, which is meaning and types of surds. So finally, we are going to look at the types of surds. Types of surds. Types of surds. What are the different types of surds that we have? I believe you have taken down the objectives. So let's look at types of surds. Types of surds. Surds can be monomial or binomial. So surd can be monomial or what? Binomial. So, right? A monomial surd. A monomial surd contains only one term. Examples: we have root 2, root 3, root 5, root 11, 4 root 2, 6 root 11, 10 root 3. All these are monomial surd. Just a single term. A single term. That's monomial surd. So a monomial surd contains only one word, one term. That's monomial surd. Then the second type of surd is a binomial. A binomial surd contains two terms separated by either an addition sign, or subtraction sign. So a binomial surd has two terms, and these two terms will be separated by either an addition sign or what? Subtraction sign. There is one other thing that we need to take note of as far as the binomial surd is concerned. In a binomial surd, at least one of the terms must contain a radical. So examples of binomial surd can have 4 plus root 3, 5 minus root 7, can also have 2 root 2 plus root 3, 11 root 2 plus 8 root 5, can also have root 11 minus root 3. Now you look at this. Binomial. We say they contain two terms separated by either an addition sign or subtraction sign. Then we also say that at least one of the terms must have what? One of them must contain what? A radical. One of the terms must contain a radical. So if we look at this, there is a radical here. There is a radical here. At least that means both terms can still contain what? And still contain radical. So here we have radical and radical. Here radical and radical. Here radical and radical. So whenever you have a binomial surd, there must be a radical in at least one of the terms. And remember, we said that the terms must be separated by either addition sign or what? Subtraction sign. That's the minus sign. So when you see something like 3 plus 5, this is not a binomial surd. It's not a binomial surd because we don't have any surd here. We don't have a radical on any of this. All right, so far so good. I believe that you have just enjoyed this little moment, and as far as this particular class is concerned, we have succeeded in making sure that you know the meaning of surd, and that also you know the types of what? Of surd. But I want to give you a takeaway question. Just a little takeaway. Yeah. Takeaway question. Takeaway question. Takeaway question. Write down 5 binomial surds. I just want you to, on your own, just put down 5 binomial what? Binomial surds. Yeah, just do that. We shall be back, and when we come back, we are going to look at the basic laws in surd. Remember, there is every need for you to follow us on Facebook and also subscribe to our YouTube channel. Your comments are very, very important. Just leave comments for us, the areas you want us to improve in our video, and definitely we will improve in those areas. If you have any question, you can also contact us through our email, and also you can contact us through our Facebook page, and we will not hesitate to come to your aid. Thank you, and God bless you. Till I come your way again, continue to enjoy Mathematics Meal. Thank you.